the PRIZM tool for either new users or people who just haven't used it in a while. So this will kind of introduce you to what PRIZM can do and then what we can do with that data once we have it in PRIZM. So today's agenda is going to be kind of doing the getting started with PRIZM. We're going to be importing alias and ASCII curve data into our project here. We'll be building a PRIZM template and then importing and using core data within that template. We're going to create a UDE, or a user-defined equation, so that you can define your own curves and then what we can do with that data. Then we'll run some curve calculations and save that data out into Zone Manager. And then we'll look at using that template that we've created in PRIZM inside of a cross-section so we can do our correlations and pick tops. So first, we're just going to kind of talk about what is PRIZM. PRIZM's our petrophysical analysis tool, so we use for log analysis, so we can analyze and interpret that data when we import it into our project. All that data is tied to a specific well, so you can have multiple different curves in there for each well. We can integrate that and do that analysis all in one program, but much like every other tool within GeoGraphix, all the other tools are integrated. So information I'm looking at here in PRIZM, I can then use that data in well-base, in cross-sections, build maps out of that data, take it into smart section. Everything is all integrated all in one here. And we also have a quick analysis using our built-in custom algorithms. Those are our UDEs. We have some that are pre-built and others that will be defined by the user themselves, entering in their own equations and their own variables and information there. And then we also have the ability to apply templates to other modules of the software, namely X-section and Smart Section cross-section viewer. So without further ado, let's go ahead and jump into the demonstration and look at the tools in action here. So I'm going to start first in Product Explorer. A lot like anything else inside GeoGraphix, there's different places you can import data. Well data you can import in Wellbase and Product Explorer. PRIZM data much the same way. I can import alias data either from Product Explorer or from the PRIZM tool itself. So we're going to start first within Product Explorer and import some alias data here. So we're going to do a file import log curve. And from Product Explorer, I only have one option, so it makes it a bit easier on ourselves. When we open up PRIZM, we'll see we have a couple different ones there. So I'll choose that. And I'm going to go and I'm going to find my data. So I've opened up my, my folder here that has the curve data that I'm going to be importing. Now when you're importing the data, you have a couple options here. I can choose a single file to import. I can choose a batch of files by holding the Shift key here and grabbing them and then saying open, or just open up a folder that has a bunch of different alias files and say import all alias files in directory, and I don't have to pick and choose which ones I want to import. Just say anything inside this folder that's an alias file, import that. So I'm going to start with this first batch here and say open. And when you run the import, the first window you're going to see is how are you going to be importing this data. So we have three different import options here. Automatic mode, which basically just says, okay, I'm going to look for the well ID inside the file and the well ID inside your project and correlate those together, and that's going to be my curve data for that well. Import Wizard allows you to pick and choose a few options, namely with curve sets and kind of how to handle unassociated curve data, meaning if a alias file you're bringing in does not automatically tie to a well, you have to choose what to do with that data. Manual mode will stop and ask anytime new data is needed during the import process. So again, with wells that are unassociated, anytime there's any curve set information that doesn't match up, it will require you to make some choices while you do the import method there. So for this one, I'm going to do automatic mode and let it finish here. And so it just goes through all those files and says, okay, here's the well ID, here's the well ID in the project, put those together, data's associated. When I'm done with the import, I'll see this message pop up here, and I have one unassociated well in the project, and on the other side, all the wells in my project currently do not have curve data associated to it. So looking at this data, I can see that my well ID for the alias file is titled GRI16, and the well in the project has the well ID API number itself. So the alias file didn't match exactly with the data in Wellbase, so I need to associate that myself. So I'm going to highlight that alias curve there and then associate it with this well, and I'll click the Associate Curves button. And I'm associating this data with this well and say OK. And so now all that information that was unassociated during the import process is now associated with the correct well. And so I can always just see data that's unassociated in wells without curve data, or list of every single well in the project, as well as all the curve data in the project. So I can go ahead and click OK there. So that's my first import. Now I have data inside Wellbase that'll show me, here's all your wells with curves. I can highlight that common filter and apply it. And so you see I have 17 wells in my project that have curve data. And I can go through there now, clicking the vector button and viewing the curves that are associated to each well there and what their start and stop depths are and the step information for the curve data. So anytime you're looking at maybe looking at the data and making sure it's correct, you can always go in here and check the vector button and see maybe you have a step value that doesn't make any sense, or a top and base depth values that don't make any sense. Come in here and check that information. Okay, so that's my first import setting there through Product Explorer. You saw just one option with alias data. Now let's go ahead and open up PRIZM and we'll import data that way. So when you open up PRIZM for the first time, you see the message box pop up here giving me a list of all the wells in my project that currently have curve data. As you can see, I have 17 that I saw there in Wellbase. I'm going to click cancel here right now. We'll come back to that later. And I'm going to run another import. So file, import, and you'll see now I have more options in here. Alias still being the most common one that people use these days. I don't think I've seen many other types of curve data coming in, but we do take LIS, TIFF imports, DLIS, ASCIIs, and then our core data and survey imports that can be done here inside PRIZM as well. We'll look at core in just a little bit. So I'm going to choose the LIS import again here, and I'm going to grab a few other files down here at the bottom. Before, when I did the import, each well only had one set of curve data coming in, only one alias file associated with that well. These next 4 here are 2 files per each well. What these are going to do are merge and splice the data together so that everything is associated when it comes in. So I'm going to click open, run automatic mode again here. And now that's brought that data in there, and I don't have anything unassociated. Well ID in the file matched the well ID in the project, so everything's automatically applied there. So now I want to see what kind of data I have in my project. Let's go ahead and take a look at that. I'm going to come up here to Project, and then Curve Inventory, and let's go to Curve Set Inventory. This gives you a list of all the wells that have curve data imported into your project, and then which import set that data came into. So for the first well, only had one import file for it, so import 1 was the name of that import. And here's my start and stop depths in the step, as well as the curves that came in from that file. So for the first well, I have an LN, an SN, and an SP curve. And I can go down the list and see other wells and their associated curves. And then at the bottom, those 2 wells that I just imported, GRI 20 and 21, have the merged sets. Well, the first one has a merge set, the second one is a splice set. What the merge does basically is say your first import had these curve names here, and the second one had these curve names here. I'm going to merge all those together into one curve set instead of having 2 separate ones. So now I have one curve set with all those curves together. The second well here, GRI 21, had curves that are the same name in a few places but cover different areas. So what that does is splice the data together to create one continuous curve. So you can see 4200 to 6990 and 6935 to 8000. So it creates one set covering 4200 to 8000 feet, and then creates a splice depth at, I believe it's 6935. That's a value that you can set within the options within PRIZM at which depth that splice starts to occur. So I covered that whole span of the entire well instead of just one portion of it, so everything's spliced together. Okay. So that's my first two imports there. Now I have some curve data covering a lot of those wells. I'm going to run an ASCII import now through PRIZM. With the alias import, everything's already mapped out, and the curves know what their values are at each depth as you import that data in. With an ASCII file, it requires you to do some manual mapping of yourself. So I'm going to go ahead and grab that here, the GRI18 ASCII file. And then I'm going to say, put in the well ID, which is the first row of data. So I'm going to say it's 42273, put the well ID, the well name, and the well number. Okay, so all that information will typically be the first line of the file. If not, then you'll just manually enter in that information, which you'll know ahead of time. After that, now I see a second row here that gives me a list of all the curve names as well as their units, and then underneath that's the data itself. So I highlight the first row of data, and then I'm saying, okay, the first column, that's my depth column. I need to map that out as depth with units of feet. And then I'll go on down the list. So the next curve is MPSS. If I click the drop-down box, I don't see an MPSS curve. These are my default curves, and these are kind of pre-set up by the program, but you can edit these yourself. We'll look at that in a minute. So if I don't see the curve name here, I can just type it in myself, MPSS. Units are volume over volume. And then I'll continue down. This is ILM. Units are usually filled out automatically with if it's a default set. GRD here is ohms. GR, row B. And just a few more here, PEF, SP, and ILD. So again, all these are mapped out there inside the file. I just need to physically tell it what each column is and what their units are. So a lot of the information will be automatically filled out. And then at the bottom is my interval, indicating where the information starts and where it stops and what its step value is. All of that is editable. I can change that if I need to there. One more thing I need to do during this process is tell it that there is some null data in here. I don't want to have a curve value at the value of 999.99. So I need to indicate that there is null data in this file. Nulls are indicated by that value, 999.9900. Okay, so I got everything mapped out there. I've got the first row of data highlighted. Everything looks good, so let's go ahead and run the import. And when I do that, it's telling me that there is this GRI18 well doesn't exist currently as far as curve data goes. You'll see I'm missing a GRI18 over here, so I need to import this into a new well for PRIZM. So I'll say OK. And now I have a GRI18 in my curve set inventory over here. That came in from the import curves set. So you see there's import 1 from the alias, import curves from the ASCII file, and there's all those curves that I imported. Another way you can view the curve data is in the curve inventory and the curve mnemonics. This gives you a list of all the curves that you have currently imported into your project and how frequently they show up. So I have one well with the caliper, one well with the DRHO, 16 with the gamma, or 15 with the gamma ray, and so on down the list, as well as anything that is being aliased to that curve. And again, these are the default curve names. So when you import data, sometimes users will have different naming conventions for a lot of their curves. It may not look exactly like these names. We have an alias set up automatically to pick up on some of the other naming conventions. But it's not always the case that we're picking up on those names. Sometimes people have their own unique settings for that. So we might need to be doing some of our own curve aliasing ourselves. So we're going to do that here in the default settings. And when I open that up, I see a list of all my default curves in the project. And again, these are kind of the pre-set up ones in PRIZM. I can add as many default curves as I want in here. So they'll show up in those drop-down menus. For instance, my MPSS curve didn't show up during the import process when I clicked the drop-down menu, but I can add it here, and then from now on, any drop-down menu where I'm looking for a curve name, it will show up. So let's look at that curve, the MPSS. That is a neutron porosity curve. So I'm going to look for my neutron porosity curve name in my defaults, the phi n. And you'll see a list of all the curve names that are alias to it. So I have an NPhi, CN, CNL, CNC, so on and so forth. You can have as many names as you need to here. I'm going to click the end button on the keyboard, go to the end of the list, and I'm going to add my own curve name. So I'm going to put comma and then the MPSS. And now that name is now alias to phi n. So anytime I'm trying to display a phi n curve and I don't have phi n, it'll go down the list and it'll find MPSS and display that curve for that well. As I said, you can add other default curves in here. Default parameters are going to be your variables when you're running UDE calculations. Each variable will have a value and a description of what it is. For instance, here's the A. It's got a value of 1, and it's the Archie A value when you're running an Archie equation. And you got a couple other in here, gamma ray shale. There's a V shale in here, or V shale cutoff, water saturation cutoff. And again, you can go in here and add your own parameters that you want to apply in here as you build equations that are the default ones. Later on, when we're building UDEs, we'll look at just creating our own parameters and defining them through the UDE. Conversions can be applied to the curves and their units in here. If I have a curve that's in degrees Celsius and I want it to be degrees Fahrenheit, I have an input and output set up here saying any data coming in that's degrees Celsius is going to be converted to degrees Fahrenheit. Here's the multiplier and the offset for that equation so that I can output the correct units. And again, always able to add new information to that. Here's my units. Units that are going to be for my curves in here. Again, these are default units. I can come through here and add more if I need. These are the default settings that are pre-set up when you first install the software. So anytime you need to edit these, this is where you come to add new information to that list. So that was one way to create an alias for a particular curve, our MPSS alias to our phi n for our neutron porosity. I'm going to go back to that curve inventory that we were looking at before and look at another method of aliasing curves. I'm going to curve mnemonics. And I'm going to look at these two curves here, the LAT and the LN curves. These are some resistivity curves that need to be aliased to our res-D. So I'm going to go ahead and highlight one of them here and say add as alias curve. And I'm going to alias it to res-D. Say OK. And so now here's all the other curves that are alias to res-D, ILD, RILD, LLD, res-D, all caps. Again, curve names are case sensitive, so be careful about that. AT90, A090, or AO90, sorry. And then the LN that I just added in there. And so now I can add more aliases that I need to here. Let's grab that LAT and add that to the list. So again, what the alias does is it says, okay, you want to display a res-D curve in this track. Let me go and find a res-D curve. It's like, okay, res-D doesn't exist. Let's go down the list. Do you have an ILD curve? Yes, I'll display that. And if no, then it goes on down the list. So you can set up a hierarchy of which curve will take precedent in the case of aliasing. So if I wanted my LN to be the first one that it looks at, I can move that up the list to the top and have that be the first curve that it looks for in the list of aliasing. Go ahead and click OK there. And click Close here. Okay, so we've looked at bringing that data into my project here through alias imports. We did an ASCII import. And we looked at, once that data is in there, I need to make sure that I've got the correct curves for those wells using some aliasing, indicating that, okay, if I don't have this particular curve name, then look for this other one. Again, all that's kind of set up through the defaults. When I look at my first template here, it's using some default curve names. I can go in there and choose whatever curve names I want to be. So in some cases, you don't have to alias ahead of time. So let's go ahead and look at that. Let's go ahead and open up the first well, GRI number 1. When I get there, I get the list of all my wells in the project that have curve data. I've got 20 wells here. Or I can get a list of every single well in my project. Again, this is a small project, so I think I only have one more well in here that doesn't have curves. But it just kind of shortens that list, so it's a lot easier to find data with that wells only with curve data. So let's highlight the first one here and say open. So when I launch PRIZM for the first time, my defaults are set up to open up this template here called raw curves and not have any UDE applied to it. If I come up here to my project and go to interpretation sets, this is what I have set up for when I open a well in PRIZM for the first time, what is going to open up for me. So I had the log template raw curves, and it will open whenever I open a well. I can also apply crossplot and a report template to open up at the same time as well. I'm not really going to talk about much with crossplots or reports, but it's just other types of ways to view that data, either in a crossplot or in a report that gives you a list of, at certain depths, what each curve value is. And then I can apply a UDE down here as well. So I can create my own interpretation set, apply that. Every time I open up PRIZM, that's what's going to open up for me. Or I can just open up templates at will whenever I choose. So I'm going to keep that as is right now, because what I need to do first is I don't really have any templates yet. I need to build my own template. So I'm going to take this existing raw curves PRT file here, and I'm going to run some edits on it to change what's being displayed and just overall some aesthetic things in here. So let's go ahead and look at that here. A few ways to edit a template. First, just simply right-click in the template and go to Edit. If I want to edit a particular portion of the template, I say something with the depth track, I can open up depth. If I want to change the number of tracks and what their names are, I can go to Tracks, view what kind of curves are in each track. I can edit that here. If I want to apply some area fills to a curve, and data posting, where I want to post perforation data, DST, IP, other type of data that's saved in Wellbase with that data, with that information. So let's start with, I can also go up here and go to Edit and the same options. So let's start in the depth track. So this is where I can control kind of this portion of the template. What view am I seeing here? If I'm in a deviated well, do I want to see measured depths or TVD values, or both side by side to kind of see what offset I'm getting? What's my vertical scale in the well going? By default, it's 5 inches for every 100 feet. You can change that to something else if you choose. I can widen the depth track. Anything else I need to do in there? What I'm going to do is I'm going to change the way that I have my horizontal grid lines showing depth values here. I feel like this is just a little too much. So let's kind of change this up a little bit. I want a thick line to show up at every 50 feet, so keep that as is. I'm going to take out the medium lines though, so let's make that 0. And then thin lines every 10 feet. And so when I apply that, it looks a little bit cleaner there now for the horizontal grid lines. So let's move on to the Tracks tab here. So with the Tracks tab, I'm able to control how many tracks do I have in a template and what type of data is displayed in that track. So the 3 I have right now are a correlation track, resistivity track, and a porosity track. These are 2 linear tracks and a logarithmic track. There's other types of tracks you can add in here: image tracks, litho curves tracks, mineral tracks, core descriptions, a lot of different options, and we'll look at some of those in just a minute here. But I want to do a little bit more housekeeping. So for these, I'm going to change the number of vertical lines that I have in my template. So I can click over here in the attributes, and let's drop this down to 5. and change that for all of them here. And you can choose to hide those all together as well and just have a blank background. Okay, so let's apply that. So again, a little bit cleaner. You can choose to add or remove as many of those lines as you need to there. When you save the template and take it over into X section, it's best to have fewer lines. When you're zoomed out to a certain level within the cross section, then the template just appears kind of a black rectangle because the resolution can't plot every single individual track line in there, so you just need to limit the number of lines you have in there. So again, I can change the width, the type, kind of what my grid left and right values are going to be over there. Okay, so let's move on into the Curves tab. This is where I'm going to apply which curves to which track. So you can see I have 3 curves in my correlation track, gamma ray, SP, and caliper. 3 in my resistivity track, deep, shallow, and medium resistivity. And then 4 my porosity track, and my neutron porosity, rho B, DT, and PEF displayed there in those tracks. And so I can go through here, and instead of phi n, I want to look for that MPSS. It'll only find MPSS in that case since nothing's alias to MPSS. And change kind of which curves are displayed and what it's looking for. I should point out here, the name of the curve is displayed over here above the tracks. So here's gamma ray, SP, and caliper. If a particular well does not have one of those curves in there, for instance, this well does not have a gamma ray, I have in parentheses here NA, meaning that it can't find gamma ray and it can't find any of the alias curves for gamma ray either, so there's no data to display. So I get an NA. SP does exist for this well, so I get an SP curve shown in there. And my res-S, my shallow resistivity curve, doesn't find the res-S curve name, but it does find the SN, which is one of my alias curves, and so it shows up there in that track. And then nothing in my porosity track for this well. So if I want to kind of make some changes in here, I can change the attributes for a particular line, change its thickness, its style, its color, change the units for it to be displayed. For instance, my SP is going from a value of -100 to 50. So that's why you kind of get the scale that you have there. You can drop that scale, increase the scale, kind of make that appear more jagged in a few cases by changing your scale there for what the values you're going to see for the curve. I'm going to leave everything here kind of as is for right now. I'll look at adding some different curves here in a little bit. Move on to the area fills tab. Area fills are going to be defined by bounding curves and bounding values, so constants. So I'm going to add 2 in here. First one I'm going to add is a sandstone fill on the SP curve, and just kind of figure out where some sandstone zones might be based on that curve. So let's go down the list here. Here's sandstone. And I'm going to bound it on the left by the SP curve, and on the right by a constant. And the constant value is going to be -10. And I can apply that. And I'm going to add one more while I'm here. I'm going to add this to my resistivity track. And let's do one with, I don't know, the color red. And on the left, let's do the, is that my res D? And on the right will be res S. I don't need to define a constant there because I'm not using it. And I'll click apply there. And so what that does is anytime my res D curve exists on the left side and my res S curve exists on the right side, I get the area fill filling in the gap between. Let's go ahead and click OK and scroll on down a little bit here. Looking at that SP curve, I want to figure out where some of those sandstone regions are. So here's one. Anywhere that my curve goes beyond that -10 value, and then out to the curve itself will tell me, okay, this is a sandstone region, and then dips beyond that -10 value on the right side, so I no longer will get the area fill in there. And so that's where the constant value comes in. Just takes a straight line down that constant value and cuts off the fill in there. All right. So one more thing I want to look at with the editing the template here is the data posting. So I can just right-click in here and go to data posting. And this is where you add the type of data you want to post along the well tracks here. I'm going to take the correlation track and I'm going to look at perforation data. I've got some perforation data stored for this well, and so I'll see it in there. Let's change the attributes. I'm going to make this a green color instead. Say OK, and then OK. And so let's scroll down. Here's my perforation data, and that data is coming out of Wellbase, where I got that data stored in the completion tab with my perforation ID. So all that information is filled out there and then displayed along the PRIZM track based on the top and base depths for each interval. All right, so I'm going to add a few more tracks in here. A few ways you can do that is you can go back to Edit Tracks and then click Add at the bottom and add the tracks that way. The other way is out here in the blank space next to the other tracks, I can right-click and then choose the track that I want to display in here. Let's add a lithoform track here. Oops, not a lithoform, sorry. I need to make that a lithology curve, lithocurves, there we go. And now with this, this track applied here, I'm going to go to my attributes and define my lithocurve. And what I'm going to do is I'm going to use a bounding SP curve like I did in my correlation track and define some sandstone and shale regions based on that, that curve. So I'm going to add in here, let's say SP curve for both of these. And then I'm going to apply my qualifier here, say anything greater than -10. That will be a shale. And anything less than or equal to -10 will be my sandstone. So like we did on the other side there, but this time we're adding in some more qualifiers for anything. The other value will be the shale lithology. And then I'm going to create a boundary curve over here on the right-hand side. Again, using my SP curve. And I'm going to set up the values here from 50 to -100. And it's linear, and I'm creating a boundary. I'm going to put the curve in there. So I'm going to display the curve itself. So I'll go ahead and click OK. And let's see what we get there. So again, based on the data that I've put in there with that -10 value, it'll define my lithology based on that particular curve. So there's the SP curve, creating that boundary there. And here's my sandstone region, lines up with the sandstone region that I created over here using the area fill. So let's look at what other kind of tracks we can add in here. Other one I'm going to look at in here is the image track. But you can see the other types of tracks you can add in here. Log and linear track are like the tracks we see over there in the first three. Minerals track is using some curves with some mineral data to kind of create some more curve displays in there. Image track is where you're going to display raster logs or any other type of images that you've depth registered for the well. Core description is just describing some core with text boxes that you kind of enter in the data for. Lithoform top is when you display formation tops inside PRIZM, then it just takes the lithology of that top down to the next top and fills in the entire area with the lithology of that track or that formation. For instance, if I had a top from 4,000 feet to 50 feet here, and it was a sandstone lithology, then I would see a sandstone fill in that region. Lithocurves is a track we see over there. Lithology is just defining the name of those lithologies from the formation tops. So that's the lithology description. Lithology track I think was something different. And the text when you're defining maybe some remarks or information about the core data or curve data that you want to display over there. So let's look at the image track here. And for this particular well, I have a image of some core data that I've gone in depth registration and registered on my own from a particular depth range. I'm just displaying that curve data in there. So what the image track is doing here is, in this case, I'm looking for that specific photo. But if I want to change that, I can go to the Tracks tab. Here's my image track, and then go to the Attributes. And it's looking for any image. So whatever image you can find for this particular well, it's going to display the first one that it can find. Much like a lot of other things, I can set up a hierarchy here. Say instead of any image, look for a porosity image. If a porosity image doesn't exist, look for a resistivity image. And these are the default image names. I can look for the particular image names that exist for this particular well. And just set up that hierarchy so that it basically will display the first image that it finds from that list and put it here in the image track. And you can put multiple image tracks to display multiple rasters. Excuse me, I don't believe there's any limit set for that. Okay, so I'm just going to keep it at any image in this case. And say OK. And then say OK here. All right. So I've got a few other things I've added to the template here. Some new tracks. So I put in some area fills, some downhole posting information. I want to look at adding some more information, but first I need to start defining some of that data. So the first data I'm going to bring in is some core data. This data will be stored inside Wellbase in the core tab. But I can import it here in through PRIZM. So you can import this in with a spreadsheet to Wellbase, or through PRIZM if you have an ASCII file of that data. You can easily import that. So let's go to core data import here inside PRIZM and grab the core data file and open. And this is for GRI number 6. So I'll highlight that well and say open. Much like we saw before, I need to map out what each going to be for this import. So I have permeability and porosity in this core file. Parse that data into columns. So here's depth. Depth is in feet. This is my permeability, which is going to be my Kmax, core Kmax. And then porosity, which is going to be core pore. And there is null data inside the file here, 999.99. So always important to map that information out so that it doesn't get imported with incorrect values in your data. Okay, so everything else is mapped out there. I got my top and bottom depth from the depth column. And this is some conventional core. If it's sidewall, you can apply that there. So then I'll run the import. And now that data is in that well inside Wellbase. Let's go look at GRI number 6 and the core tab. And there's all my core data with my porosity and Kmax values. Anywhere there's a null, it's now blanked out instead of bringing in the bad value that I didn't want in there. Let's go back to PRIZM. And now that I got that core data inside my project, I can display that as a curve here in one of my tracks. Let's go to the porosity track and let's edit that. So again, I'm displaying phi n, rho b, dt, and PEF in this track in this particular well. Oops, let me change to that well. And I can use the blue arrows up here to navigate between all the wells that have curve data in my project and quickly find the one that I'm looking for. I think this was at 6,000 feet. All right, so let's go ahead and apply that core data in here. So I'm going to put this in the porosity track. So I'm going to click Add down here at the bottom, say porosity track. Curve is going to be core pore. And I'm going to change my left and right bounding features to 0.45 and negative 0.15. And then change my style here. I'm not going to put a line, I'm going to put symbols instead. This is going to draw a symbol as close as it can to each depth value for that particular core data. And bump the size up to 2. All right. And I'll apply that, and I think can you go down a little bit more? There it is. 6,500 feet. Here's my core data. And so what this is doing is applying that symbol there as close as it can to the nearest depth value. And I can look at that if I go to curves and core curves and how the data is being plotted. So here's a porosity curve, core pore. Curve type is nearest depth. So plotting that point as close as it can to the nearest depth within the value. If my step values differ from what if the step values for the core data differ from what my step value is for display, every foot instead of every half foot or something like that, it'll display a point as near as it can to that depth. And there's a few other options in there. Okay. So now I got some core in there. Highlighting where that core curve is going to be. You see, just import that in through an ASCII file, store the data in Wellbase, and then display it there in PRIZM. So now I can use that data for other calculations as well. Okay. So I'm going to add some more data in here, but I don't have any other data from the alias files that I'm bringing in, so I need to create some of my own curves. And I want to run equations on existing data to create that. So I'm going to use my user-defined equation to do that. So I'm up here to Interpretation and select User-Defined Equation. And you see I have a pre-built one in here called ASCII, as well as some, these are PEM, PRIZM external modules, UDE sets that are defined through a module that we have where you can create your own kind of external model and then run that through, run data within PRIZM through the model and then output some different types of curves. Works a little bit differently than the UDE set. But I'm going to create my own in here. Let's just call it a webinar. So that's where you create the PEM model. And let's go to edit here. So within the UDE, we have some pre-built equations. Here's my density, porosity. If I want to display some of that data inside, you use those equations inside my UDE here. I can just select them and add them in here, make some changes if I need to, or just simply manually type in what I want my equations to be, and then making changes as I need to there. You can see a lot of different options in here: porosity, some resistivity, some water saturations. There's some ASCII equations, some permeabilities if I need to calculate any of that. Some mechanical stuff in here: Poisson's ratio, Young's modulus, brittleness indexes. Some pay flag equations if I want to set up some of that, and we'll look at that in a little bit. A lot of those are already pre-built in there, so you can use those as you need, edit them as you need, or simply pull something off of a website somewhere and run that equation by typing it in there. In the interest of time, I got a couple of the curves that I'm going to be using entered over here, so I'm just going to copy them into my UDE over here. So these are the equations I'm going to be running here. I got an ASCII water saturation equation that I'm going to be using. Some null flags in here so that if a particular curve value doesn't exist, I replace it with a different value. This is using some if-then-else language when you're like in a C++ kind of coding language in there. A lot of those can be found within some of these other equations if you're looking to edit some of them. And then I'm building these equations on my own here to run some water saturation and a pay flag within my my template here. So if I click on the there's some of the different curve names and parameters that you can apply in there. I've got some parameters in here that aren't defined quite yet, so I need to click on the apply button here. And here's all the parameters that I'm using and what their value is going to be within the equation. So if I need to change one, I can change it here. For instance, my A value, remember we looked at the default settings. The A variable is defined with the value of 1. I can change that here, and it only affects this UDE. So if I want to have a different UDE that uses a different A value, then I can change that there as well, and it'll only affect that current UDE. If I change it in the defaults, then it changes everything across the project. So with these equations, I want to kind of check the data that I have here and see what I would get. So I can click the Evaluate button. This will tell you that for a particular well that I'm looking at, in this case, this GRI number 6, row B and phi N are not defined. So I don't have any data, so it's saying that it's not defined. I can run the equation without those. So I'll click yes. And it'll say, okay, here's my input value from my equation. I'm only using the ILD, so ResD, to calculate out my pay, average porosity, and my water saturation. You can see at this depth, 4650, here's what each of those output values would be. So if I ever need to run any analysis on this and check on it, let's go to a particular depth, based on my input core value or curve values, what is my output data going to be there? So I can double check and verify that my data looks good there. If something doesn't, go back to my UDE and figure out where the mistake has been made. So once I run the evaluation there, I see, okay, everything's the way I want it to be. Let's go ahead and say, okay, here, apply this UDE. Make sure I have that UDE applied first. Okay, yep, so that's applied. So now I'm going to go and add another track over here. This is going to be a linear track. And let's go ahead and add some information to it. Let's call this, I don't know, SW track. And go to the Curves tab, and I'm going to add some curves into this track. Let's look at the phi A and water saturation curves. So it should be 0 to 1 and 0 to 1. I think that's good for this one. Okay, so I think this particular well is missing some of the data, but let's cycle through some of the other wells in here. No, I added it to the wrong track. That's why. These should be on the SW track that I just created. So as you can see, I had them over here, my porosity track showing up there. I need to correct that and put it in the correct track. So always something you need to check, making sure that the data is in the correct area there. So I'm going to make a few quick edits here. Let's make this one red, and let's make this one blue. All right. So now I can view my parameters changed on there as well. I can view my my curve data in there, my water saturation and my average porosity. So that I can analyze some of that data. Now I want to look at, make another track over here. And with this one, I'm going to look at my pay flag, my pay cutoff that I created within that UDE. So let's go and look at that. So this will be track 7. And let's look at pay and water saturation here as well. So I'm going to make these a little bit different than the other one that I was looking at over there. Instead of displaying an actual curve, I'm going to display a flag instead. Get the correct values over here. So I'm not going to have any curve line showing up here. It's just going to be a flag. So anywhere I have a pay zone, I'm going to get an area fill in there for it. And then same with water saturation. Okay. So let's look at that here. I don't have any of my pay showing up in there. Let me see in here. I had something different. area fills. Okay, so I'm going to add the pattern in here. It's going to go in that track 7. I need to do an area fill for my flag for both the for my pay and my water saturation. So let's go ahead and grab those here, gas and water. Gas is going to be pay, and then constant value of 1. Water is SWA, and constant, or I'm sorry, it's constant SWA. No, that's right. Okay. And so I get my my area fill in there with my curve there for the water saturation and my pay zones based on those pay and water saturation curves that I displayed in the UDE. So I've got all this displayed here inside my my template. Now let's run some calculations on it. I want to take some of that data that I've used here for water saturation, for my average porosity, and for my pay zones, and I want to send that out to Zone Manager so I can use some of that data to display either on a map or for displaying, so running some calculations on it elsewhere. So let's run some data statistics on there. I'm going to go up here to Interpretation and Curve Data Statistics. So let's take those curves. Let's take a gamma ray. I want to run an average starting at the F11 top down to the total depth of the well, and add that one in there. So what that's going to do is it's going to take my gamma ray curve, figure out an average for each well, and only calculate from the top of the F11 formation to the total depth of the well. And I can do this for multiple different types of curves. Let's also do a phi average from the C38 down to the total depth of the well. Add that in there. And then let's do the pay calculation. And let's do a sum times height on that from, I'll just do the whole well there. So you can apply multiple different types of settings for each curve, and then what type of statistic you want that calculation to be run on. And if you have a particular Zone Manager zone already set up, then you can define, or you can limit that area down to that particular zone. In this case, I just have the well zone, the whole well, so I don't need to apply anything there. So let's go ahead and create the data. Oh, I didn't add that in there. Now let's create the data. And you'll see each value here, average gamma ray from the F11 top down to the total depth of the well. Each well that has a gamma ray curve, these don't have gamma ray curves, will have a value in there. Here's my average porosity for each well from the C38 top down to the depth of the well, and then my pay summation zones listed over here for the entire length of the well. Now I can take that data and let's save it to Zone Manager. And you'll basically define the zone and the attribute that it's going to go into. Oops, oh, I already have that in there. Okay, good. So there's my gamma ray average. Save the zone and attribute names. This is going to go to my phi average. Save that. And then here's my pay zone. Let's create a pay attribute. And use that. And save the zone and attribute names. And then I'll save all that data out to Zone Manager. When I go open up Zone Manager, I can look at all that data. Oops, close everything there. I've sent all that data out into Zone Manager for all those wells, and so I can look at that data here and kind of look at what I have. So there's all my values stored there in Zone Manager. I can now use these to run calculations on, build maps from, anything else I want to do with that data. So the last thing we're going to do here is just look at applying templates to a cross-section. So I'm going to come back in here to my map. This is just a well-based layer that I've got here of all my wells. I'm going to define a cross-section from this particular area. And I have a cross-section template I want to use just to create a depth cutoff. And then I need to apply my template. The first thing I need to do is actually save the template. So let's do File, Save as Template, and save the template here. This is a PRT file. PRTs can be copied and pasted from one project to another, so if you'd like a template that someone else is using and you want to use it in your own project, then you can copy that from one project over to another, or one user over to another if you're not using any network projects. Okay, so I got that, that template saved. Let's go ahead and apply it here. Edit Wells Logs and apply the log template. And there's all my data. But now I'm looking at this, I'm saying, well, those last couple tracks don't have any curve data in there when I distinctly saw that I had that data in there. One thing you always need to check is whenever you're applying a log template is also choose the same UDE that you're applying back inside PRIZM. So I'm going to grab the webinar UDE set here, say OK, and now there's the rest of my information. My water saturation curves and pay and water saturation flag zones listed in there. So I can take all that data, import it all into PRIZM, run my calculations and analysis, build my template, send it out here into the cross-section, and now I can start using this for correlation when picking tops. So go ahead and conclude here. So PRIZM, it's an easy-to-use analysis tool, integrates with other modules to view and correlate data with formation tops and maps. So all that data that we saw that we were looking at there in PRIZM, I can now use in multiple other programs, and well, everything within GeoGraphix is integrated. User equations and the curve data statistics help us run calculations on the user input curves and output new data. So everything is all editable. Everything that you bring in from those alias files, you're not just contained to that. You can take new data out of that with those equations. And the templates are fully controlled by the user and then used in cross-section for any kind of analysis and correlation that you want to do in there.